Good morning. So I'm going to do a quick run through on empirical formula again. So let's remember that this is mercury forms a compound with chlorine. And so what we're looking for, guys, remember is, mercury, Hg. We want to know what its subscript is with chlorine and its subscript. So what I'm looking for is the subscripts here. And if you remember, when we look at this, we say there's so many moles of chlorine to so many moles of mercury. So what we're needing here, guys, all the time is moles. So if in doubt, I always say take your problem to moles, and then that will guide you on what to do. So we're just going to go ahead and get started. Anytime they give you a percentage, we can actually just turn that number into grams, because what we can think of is that if it's 73.9% of 100, then it would be 73.9 grams, and that is of mercury. Okay, and then we're going to take the same thing here, the 26.1. Again, if you think of it as out of 100 grams, then it would be 26 grams of chlorine. So again, the rule is that we take everything to moles. So we're going to do our railroad tracks. We're just doing a gram to mole conversion. Reminder, guys, that if you have grams in the numerator, grams goes in the denominator. Okay, these have to match up. Same thing here, grams of chlorine, grams of chlorine. And anytime you go from moles to grams or grams to moles, you have to have the molar mass. So in this case, we're going to look up mercury and find its molar mass, which on this periodic table, it's 200.592, but maybe on yours it's 200.6. Okay, if not, whatever it says there. And then again, for 1 mole, okay, 1 mole of mercury. So again, remember, guys, whatever the value is here, that's always for 1 mole. That's what that is. And then we're going to do the same thing for chlorine, 35.45 for 1 mole of chlorine. Okay, so again, don't forget to cancel. And since 1 is in the numerator and 1 is in the denominator, we're going to do a division problem. So I'm going to go ahead and divide this one out for you. So 73.9 divided by 200.6. So I get, and we need 3 digits, 3, 6, 8. And that's moles of mercury. So get your labels. And then we're going to do the same thing here. And this is moles of chlorine. Okay, so once you get your moles, the next thing that we're going to do is we just want the ratio of these two together. And so to get the ratio, it is the easiest thing to do is just divide the moles, and we want to divide by the smallest. So I look at these two, 0.3, 0.7, 0.3 is the smallest. So we're going to divide both by the smallest. So of course, when I divide this one by the smallest, it's just going to give me 1. Okay, that's not surprising. Chlorine, when I take it and I divide it by the smallest, okay, so in this case, we're going to get, let me just run this, 0.736. And it may not come out exactly divided by 0.368. And no, that did. Awesome. It came out exactly 2. Exactly 2. And so all that means now is that Hg1, which I really wouldn't put the 1 there, but I'm going to show you where that's coming at, Cl2. And then that would be my empirical formula. Now remember, if they gave you the mass for a molecular formula, then you would need to find the mass of this and divide it into the molecular formula to see what multiple it is. And that's what the next problem does. So I'm just going to set up this next problem for you on there. So if you're watching this video, one, I would pause it and try it on your own, and then come back and see if you agree with what I did. Okay, because if you don't do it on your own, you're not going to know if you know how to do it correctly or not. So again, I suggest you pause it and then come back. Okay, so we're going to take the 75.42. Again, it's a percent, so I'm just going to put a gram there. I'm going to do the same thing with hydrogen. I'm going to do the same thing with nitrogen. And I'm going to do the same thing with oxygen. So this one's got a lot of steps, or a lot of elements, not just the two. Okay, so that's the first step. The next step is, again, we're going to go from grams to moles. So whatever's here goes here, okay, so that they cancel. And it's always for 1 mole. And then I go to my periodic table. I find carbon. Carbon is 12.01. Okay, those are going to cancel. And again, this is going to give me my moles of carbon. I'm going to continue on with each one of those and do the same thing. So I'm going to, on my video, I'm going to pause it real quick and go ahead and give you the numbers. Okay, so I went ahead and put all the molar masses in for you. Again, you should do your cancellations. So if you'll look, all I have left is moles of hydrogen here. Grams, grams. Again, your molar mass goes in the denominator. Your moles is always going to go on the top when I'm going from grams to moles. And then I'm going to do the same thing on oxygen. So cancels, cancels. So in each case, the only thing left as a label is moles of the element. Okay? Now, again, since one number is in the numerator and one's in the denominator, this is going to be a division problem on each one of those. Each one of them, well, this one has 4 significant digits, but each one of these has 3. So again, if you have not done that, I would go ahead and do your division and see if you agree with me. Okay, so I went ahead and divided those out. I ran my numbers together here, but this is 6.280, 6.56, 0.598, 0.598. Now again, the next step, once you get your moles, is to get the mole ratio. So we just want to divide by the smallest here. So for carbon, I'm going to take the 6.280 and I'm going to divide it by the smallest, which is 0.598. And so when I divide those out, I get 10.5. Okay, and since I have just 3 digits, that's all I need there. So I need to go through and divide each one of these again by the smallest. So that's going to be my next step. So again, I'm going to pause it and go ahead and run the numbers. I would suggest that you do the same. Okay, so I did do a couple of things here just to want to show you. So when I divide these out here, I got 10.97. 9698 actually is what it is. We only needed 3 digits, so technically I'm going to round to here, but if you look, all that's going to round up. So really this number is going to be an 11. Okay, an 11. Now, I do want you to look, because this is 10.5. We talked about this when you have a 0.5 or maybe a 0.3, something of that nature, is that we need to now make all of these whole numbers. So we would not round this one up. We're going to leave it 10.5. So now what I'm going to come in and I'm going to double everything. So 10.5 times 2 is actually going to be 21. Okay. 11 doubled is 22. 1 doubled is 2. And 1 doubled is 2. So my actual mole ratio that I have here would be C, 21, H, 22, N, 2, O, 2. Okay, so that would be my final answer. So don't forget, if you get one that's a 0.5 one that's like a 0.3 repeating or something. If it was a 0.3 repeating, you would triple everything. But this is a 0.5, so we're going to go in and double everything. So don't be surprised if you get one that doesn't come out to a whole number like this one did. This one came out to a nice, neat whole number. Again, the 0.3, you would triple everything. The 0.5, you double everything. So don't be surprised if you see those. Okay, so this is 24 and 25 on your study guide. Definitely you'll have one of those on the test.